In this video, we are going to use expected value to determine expected gain or loss in real-world problems. So expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. Expected value is the anticipated value of investment in the future. So there's two different ways that we can calculate expected value that we have listed. The first way is the standard way, and you're going to multiply each possible outcome by its probability and then add these products. And then it is also calculated by multiplying the gain or loss for each possible outcome by its probability, and then you take the sum of these products for the gain and the loss. The first exercise, we are going to be using the standard way to calculate expected value. We are going to multiply each possible outcome by its probability and then add these products. So we have probabilities for homeowners insurance claims. We have the claims 0, 50, all the way into 250,000. And then we have the probability of homeowners filing these claims for these amounts. So we are just going to multiply all of these amounts. Whenever we multiply these out and add them all up, we get 29,000 as our expected value. So this is the expected value for the insurance company. This is like their expected value of how much they're going to pay each homeowner, almost like an average. How much should the company charge as an average premium so that it breaks even on its claim costs? So if they're going to pay this amount, this $29,000, to each homeowner, how much should they charge to break even? And the answer is $29,000. How much should the company charge to make a profit of $50 per policy? Well, if you're breaking even at $29,000, you would have to charge $29,050 to make a $50 profit. All right, number 2, the rest of these we are going to use the second option for expected value. We are going to multiply the gain by its probability and then add it to the loss and multiply that by its probability. So number 2, a construction company is planning to bid on a building contract. The bid cost the company $1,500. So in order to even get in on this bid, they have to pay $1,500. The probability that the bid is accepted is 1/5. If the bid is accepted, the company will make $40,000 minus the cost of the bid. Find the expected value in this situation. So to find the expected value, we are going to take the gain times its probability minus the loss times its probability. So what this means, on this construction company, it says that they will gain $40,000 if they get this bid. So $40,000 is what they will gain. But we can't forget that we put in $1,500 for this bid. So we have to take that $1,500 out. So this is what we gain. We end up gaining $38,500. And then we're going to multiply our gain by its probability. So the probability that the bid is accepted is 1/5. For our loss side, we lose if we do not get this bid. So that $1,500 that we put in to even bid on this project, we lose it. It goes out the window. And then the probability for that, so if the bid is accepted, we have a 1 out of 5 chance of getting that bid. What that means is that we are one of 5 companies who are bidding on this project. So that means that if we were not to get the bid, our probability of not getting the bid would be 4/5. A full circle makes 100%. All right, so we are going to take 38,500 times 1/5 and then subtract 1,500 times 4/5. And we get 7,700 minus 1,200. Our expected value is 6,500. Number 3, a 25-year-old can purchase life insurance for $10,000 at a cost of $100. Past history indicates that the probability of a person dying at the age of 25 is 0.002. Determine the company's expected gain per policy. So we're looking at the company's expected gain. So it says that they will sell you an insurance policy for $100. So this insurance company makes money whenever the people live. Whenever the people die, that is whenever they have to pay this $10,000. So our expected value, we have our gain times the probability minus the loss times the probability. So the probability that they give us is the probability of the person dying, which is 0.002. So that means that if the probability of the person dying is 0.002, what is the probability of the person living? Well, both of these have to total to 1. So that would mean the probability that the person lives is 0.998. So in order for them to gain money, the people have to live. So they gain $100 per policy, and the probability of them gaining that money is 0.998. And then the loss, so they lose $10,000 minus the $100 that they get for each policy. So they really lose $9,900. And then the probability of them losing that money is only 0.002. So whenever we multiply this out, we get 99.8 minus 19.8 gives us $80. So they're most likely going to gain $80 per policy. All right, last problem, number 4. For many years, organized crime ran a numbers game that is now run legally by many state governments. The player selects a 3-digit number from 0 to 999. There are 1,000 such numbers. A bet of $1 is placed on a number. If the number is selected, the player wins $500. If any other number is selected, the player wins nothing. Find the expected value for this game and describe what this means. So our expected value, we are going to take our gain times its probability minus the loss times its probability. So our probability of winning, we win whenever we pick that one number. So it says in this case, we're going to pick 115. So that is one number out of 1,000. So our probability of winning is 1 over 1,000. That means that our probability of losing is 999 out of 1,000, because there's 999 numbers left that are not winners. So it says that we win $500 if we pick that number that is selected. But don't forget, we had to put in $1 to play. And the probability of us winning is 1 out of 1,000. And then our loss, we lose $1 every time that we play and we don't win. And our probability of not winning is 999 out of 1,000. So whenever we multiply these together, we get 0.499 minus 999 gives us negative 0.5. So that means it's negative 50 cents. So we have a negative 50-cent loss every time that we play this game.